Module 5. The atomic nucleus. The atomic nucleus is the central part of an atom that contains protons and neutrons. In this chapter, we will explore the content of the nucleus, radioactivity, different types of radioactive decay, radioisotopes and half-lives, and some medical applications of radiation and radioactivity. An atom is the smallest piece of an element, consisting of a nucleus composed of positively charged protons and neutral neutrons, surrounded by negatively charged electrons in shells. The atomic number of an atom is determined by the number of protons in its nucleus and defines the chemical properties of the element. Neutral atoms have an equal number of protons and electrons, resulting in a net charge of 0. The mass number of an atom is the sum of the number of protons and neutrons in its nucleus. The content of the nucleus. The nucleus of an atom is made up of protons and neutrons, which are collectively known as nucleons. Protons have a positive charge while neutrons have no charge. The number of protons in an atom determines its atomic number, which is used to identify the element. The number of neutrons can vary, resulting in isotopes of the same element with different atomic masses. Radioactivity. Radioactivity is the process by which the nucleus of an atom releases nuclear particles or energy. This can occur spontaneously or as a result of an external force. The types of radiation that can be released include alpha particles, beta particles, and gamma rays. Different types of radioactive decay. Radioactive decay can occur in different ways, including alpha decay, beta decay, and gamma decay. Alpha decay occurs when an alpha particle, which consists of 2 protons and 2 neutrons, is released from the nucleus. Beta decay occurs when a neutron is converted into a proton or a proton is converted into a neutron, resulting in the emission of a beta particle. Gamma decay occurs when a nucleus releases excess energy in the form of gamma rays, which are high-energy photons. Equations for radioactive decay. Radioactive decay can be represented by equations that show the decay of the nucleus over time. These equations typically include the decay constant, which is a measure of the probability that a nucleus will decay per unit time. The half-life is another important concept that refers to the amount of time it takes for half of the original sample to decay. Nuclear equations are a way of representing the process of nuclear reactions, which involve changes in the composition of atomic nuclei. In a balanced nuclear equation, the sum of the atomic and mass numbers on both sides of the equation must be equal, indicating that the reaction conserves mass and atomic number. There are several different types of nuclear reactions, including fusion, fission, and alpha or beta decay. Fusion reactions occur when 2 light nuclei combine to form a heavier nucleus, releasing a large amount of energy. An example of a fusion reaction is the process that powers the sun, where hydrogen atoms fuse to form helium. Fission reactions occur when a heavy nucleus is split into 2 or more lighter nuclei, releasing energy. Fission reactions are used in nuclear power plants and weapons. An example of a fission reaction is the splitting of a uranium atom into 2 smaller atoms, along with the release of several neutrons. Fusion requires more heat than fission. This is because fusion involves the combination of 2 lighter nuclei to form a heavier nucleus, which requires a tremendous amount of energy to overcome the strong repulsive force between the positively charged nuclei. In contrast, fission involves the splitting of a heavy nucleus into 2 lighter nuclei, which releases energy due to the conversion of a small amount of mass into energy according to Einstein's famous equation E equals mc squared. However, both fission and fusion release an enormous amount of energy and both have potential applications in energy production. Alpha decay occurs when an alpha particle, which is composed of 2 protons and 2 neutrons, is emitted from the nucleus. This type of decay is typically observed in heavy, unstable nuclei. An example of alpha decay is the emission of an alpha particle from a radium nucleus, resulting in the formation of a new nucleus with a lower atomic number. Beta decay occurs when a neutron in the nucleus is converted into a proton and an electron and an antineutrino are emitted from the nucleus. This type of decay is observed in many radioactive isotopes. An example of beta decay is the decay of carbon-14 into nitrogen-14, where a neutron is converted into a proton and an electron is emitted. Radioisotopes and half-lives. Radioisotopes are isotopes of an element that are radioactive. They are used in a variety of applications, including medicine, industry, and research. The half-life of a radioisotope is an important characteristic that determines its usefulness. Short half-lives are useful for diagnostic purposes, while longer half-lives are used for therapeutic applications. An example of isotopes of each other is carbon-12 and carbon-14. The difference between these isotopes is in the number of neutrons present in their nuclei. Carbon-12 has 6 protons and 6 neutrons in its nucleus, while carbon-14 has 6 protons and 8 neutrons in its nucleus. This difference in the number of neutrons results in different atomic masses for the isotopes. Carbon-12 has a mass of 12 atomic mass units, AMU, while carbon-14 has a mass of 14 AMU. Medical applications of radiation and radioactivity. Radiation and radioactivity have a number of medical applications, including the use of X-rays and radioactive isotopes in diagnosis and treatment. X-rays are used to image bones and other tissues, while radioactive isotopes can be used to diagnose and treat a variety of conditions, including cancer and heart disease. Radiation can damage cells in the body by breaking chemical bonds and causing mutations in DNA, which can lead to cell death or cancer. Exposure to high levels of radiation can cause acute radiation syndrome, which includes symptoms such as nausea, vomiting, and hair loss. Long-term exposure to lower levels of radiation can increase the risk of cancer and other health problems. To protect yourself from radiation, it is important to limit exposure by staying away from known sources of radiation, such as nuclear power plants, and wearing protective gear such as lead aprons and goggles. It is also important to follow safety guidelines when using medical equipment that emits radiation, such as X-rays or CT scans.